In this work, we present PhyScene, physically interactable 3D scene synthesis for embodied AI. PhyScene is the first framework that models physically interactable scene synthesis with realistic layout and interactable objects. We provide an overview of our pipeline. First, we leverage diffusion models with a floor plan condition for capturing scene layout distributions. Then we apply three distinct physical guidance functions for guiding the diffusion process to improve the physical plausibility and interactivity of generated scenes. Finally, we use the 3D feature for cross-dataset retrieval with both articulated objects and rigid objects. For the design of physical guidances, the first guidance is collision avoidance. Instead of calculating the collision mesh between objects, we use the predicted bounding boxes to calculate 3D IOU. With this guidance, the collision between objects is eliminated. The second is room layout guidance. We penalize the objects outside of the floor plan to ensure each object is inside the room. We use a similar IOU score between objects and walls for this guidance. After this guidance, objects outside the floor plan are moved inside. Finally, we design a reachability guidance. Specifically, we first map the generated scene to a 2D room mask and calculate the walkable area considering the agent's size. Next, we employ Gaussian distributions on each object to form a cost map. With the cost map, we plan the shortest path between the center of the two largest connection regions. We then select L agent positions on this path as bounding boxes. Then we compute the IOU score between objects and agents. With this guidance, the obstacles are moved away to connect the separated regions. We compare scene synthesis between PhyScene and previous methods. Our method shows better performance. We also compare on traditional metrics as well as our proposed physical plausibility metrics. PhyScene surpasses baselines on both of these metrics. Here we show the effectiveness of adding guidance. Adding guidance has significantly improved the physical plausibility. We also test different agent size in reachability guidance. Results show guidance on smaller size is not suitable for agent with a larger size, where the agent can only reach half of the room. And guidance on a larger size expands the walkable area to suit a larger agent and make the whole room reachable. Furthermore, to generate scenes with articulated objects, we predict the scene layout with Object 3D features. The 3D feature is acquired from a variational autoencoder trained with 3D Future and the GapHeartNet. Even the object is not shown in the scene dataset. The articulated objects have several joints and parts to interact with. Here are more results with articulated objects. We further try to build a house with an unseen floor plan from Procthor. Here is a single room generation. It is also feasible for multi-room generation. We then test the physical plausibility in NVIDIA Isaac Sim. In simulation mode, objects stay robust and articulated, objects success in driving its interactable parts. Here are more results in the first-person perspective. We also use a robot to check the agent reachability and interact with articulated objects. We control the robot with keyboard to move around the entire house. We also do motion planning to interact with articulated objects. In conclusion, we propose PhyScene, the first framework for physically interactable scene synthesis with realistic layout and interactable objects. We devise a diffusion model with three guidance functions, including collision avoidance, room layout, and agent interactiveness, to improve the physical plausibility. We predict geometric feature to retrieve articulated objects. We achieve state-of-the-art results on both traditional scene synthesis metrics and our designed physical metrics, paving the way for new research topics bridging scene synthesis and EAI.